All right, welcome. So now we're looking at example 3. Now, here's kind of neat. This is actually a real world problem. This is real. This data is actually honest to goodness real data. So let's see what's going on here. The table shows the number of daylight hours in Hamilton, Ontario on the first of each month for 1 year. Create a scatter plot of the data and draw a curve of best fit. So, okay, we've got January, February, March, April. So we should have 12 months, am I right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hey, that worked out. So we'll make this the first month, second month, third month, fourth month, fifth month, sixth month, seventh month, eighth month, ninth month, 10th, 11th, 12th. And, of course, that means that we're going by January being the first month, February being the second month, March being the third month, 6, 7, 8, 9, 10, 11, 12, and December being the 12th month. Okay. Now, daylight hours. We need to have a scale here. We need to be able to go from 9.1 all the way up to, looks like 15.2. Okay. So we're going to have a break. I think that's probably a good idea, meaning that whatever scale we start at, I'm going to start at 9.1 or 9. So if I start at 9 here, 9.1 will just be a little bit up from it, right? So, and I need to go all the way up to, I need to be able to see 15.2. So what if I do 9, 9.5, 10, 10.5, 11, 11.5, 12, 12.5, 13, 13.5, 14, 14.5, 15, 15. Yeah, that probably works. So 9, 10, 11, 12, 13, 14, 15, 16. So these will be daylight hours. And this will be month. And so, boom, let's get going. So, we're going to start on the first month, and we had 9.1. So there's 9. That's 9.5, so we'll approximate it about there. February, we go up to 9.9, so just a little bit below 10. 11.2. How about there? Fourth month, 12.8. There we go. Fifth month, 14.2. Sixth month, 15.2. Seventh month, 15.3. Yay! 14.5 for your eighth month. 14.5? Yeah, hey, that's kind of easy. Ninth month, 13.2. 10th month, 11.7. 11th month, 10.7. And 12th month, 9.2 again. So a little bit higher than what we started with. Okay. So that is a scatter plot. Now they want a curve of best fit, because obviously you're not going to have straight lines in between these, right? It's not linear in between them. It was probably a little bit more gradual than that. So as the temperature's changing, there we go. That's not a bad curve of best fit. And so you do know that the days get longer and shorter, right? And the days are pretty darn short in January and December, and they get to be pretty long in the July. So what happens is it has to do with the equinox and different things. The what's the other one called? The equinox and the, I don't remember, so I'm not going to pretend. But let's try something here. Let's go to a neat little app. Let's go to the Weather Network, and let's see what pops up here. Come on, come on, come on, come on. And let's see what we have here. What can you tell me? Well, they're going to tell me that we're going to have sunrise and sunset. Sunrise is at 5:59 in the morning, and sunset is at 20:33, which is at 8:33. So, how many hours is that? Let's calculate that because that'll be kind of fun. So we're going from approximately 6 a.m. until now. Do you know how to read 24-hour clock? So 12 takes you to noon. 8 more hours will take you to 8 o'clock, so approximately 8:30. So 6 a.m. to 8:30 p.m. So how many hours is that? Well, 6 a.m., it'll take 6 hours to get to noon. So, and then another 8. So 6 plus 8 is 14.3. So we're looking at about 14.3 hours of daylight. And today's date is, what's today's date? Today's date is, I don't even know today's date. Hold on. Come on, they got to give me the date here. It is Monday, May the 11th. So, May is going to be 5th month. So, the 5th month, come out here, 5th month. And I'm just into the 5th month a little bit, so I'll come over a little bit. And we'll go up. And we will determine that we should be about, according to this data, we should be around a little less than 14.5 hours of daylight. And we had 14.3. According to the Weather Network. So this is pretty good. And this information was from last year. So what happens is the amount of daylight that we have is periodic. It will continue this pattern as the year continues. It'll start to go up again. It'll reach a maximum of up here. It'll come back down again. This will be a curve that'll eventually look a little bit more like this. As time goes on, it'll look like that, like that, like that. Okay, and if today is day 0, then it's even going to go that way because this would be anything before today. Okay, that's kind of neat. So, does this represent a periodic function? Yes. It definitely does. Explain your reasoning. Well, there is a definite pattern. There's a definite period, and there's definite amplitude, and there's a definite cycle. So a cycle appears, and it has a period. Now, what's its period? 12 months, 1 year, and it has an amplitude. Now, our amplitude goes up to, we can read it in the chart, our highest one was 15.3, and our lowest one was 9.1, so it's max minus min divided by 2. So in this case, it's actually going to be 15.3 minus 9.1. So it doesn't get changed to a positive because we're only looking for half the distance between here. So we actually have to remove the 9.1 from the 15.3 to get an actual distance there. So using a calculator now, you're going to take 15.3. 15.3, you're going to subtract 9.1, and you're going to divide by 2. And you get 3.1. So we have, those are hours, right? Hours of daylight. So we have an amplitude of 3.1. And what that means is that if we were to find a middle point in this curve, some sort of middle value, we would be going up 3.1 and you would go down 3.1 from that middle horizontal line that's going to cut that curve in half. Now, before, all of our curves were kind of symmetric about the x-axis. This one isn't. So your amplitude now is going up from this horizontal middle line and down to the horizontal middle line, and that's what we call amplitude. So what are the maximum and minimum number of daylight hours, and when do they occur? And we've done that. We've answered that. So, ladies and gentlemen, you have a minimum number of daylight hours was 9.1, and it occurs in December. And a maximum number of daylight hours is 15.3, and it occurs in July. All right, ladies and gentlemen, that's it. That's me out of here. I'll put up some questions for you to do, and you can submit them, and we'll go from there. Talk to you soon.